In March 2020, the world as we know it was turned upside down. Our social relations, our joy, and our way of life were put to a halt due to the coronavirus pandemic. We suffered, but we did not give up. We decided to work together, to adapt, to move forward, to redefine our lives, and to continue creating a better world while living with the virus. A group of scientists and researchers aiming to have a positive impact on the world. We have been working together since March 2020, helping the Valencian government make better decisions during the pandemic using data science and AI. The XPRIZE Pandemic Response Challenge, sponsored by Cognizant, has offered us an opportunity to expand our work. Would you like to know more about it?
I remember the days, always at the same place, the same people every day.
We are Valencia IA4COVID, a diverse, multidisciplinary team of scientists from several universities and research centers in the Valencian region of Spain. We've been working together since March of 2020, helping the president of the region make more informed decisions through AI and data science. We've been focusing on 4 areas. First, large-scale human mobility modeling via the analysis of mobile data. Second, the development of computational epidemiological models. Third, development of predictive models, for example, to predict the number of intensive care units, hospitalizations, or even infer the prevalence of the disease. And fourth, a very large citizen science project via the COVID-19 Impact Survey, which is one of the largest anonymous surveys in the world with over 500,000 answers. I'm Nuria Oliver. I am a computer scientist and an expert in human-centric AI. Since March of 2020, I have been volunteering as commissioner to the president of the Valencian region in Spain on AI and data science against COVID-19.
Hi, I'm Alberto Conejero and I'm Professor of Applied Mathematics and Data Science at Universitat Politécnica de Valencia in Spain.
Hi, I'm Adolfo Lopez and I work as a bioinformatician in SEIR. I'm expert in biomedical data analysis, from omics data to medical imaging.
Hi, my name is Aurora Mula and I'm working as data scientist and researcher at Fisabio and Miguel Hernández University of Elche.
Hello, my name is Elisa and I am working as mathematical researcher at the Institute Center of Operation Research of Miguel Hernández University of Elche.
Hello, my name is Eloy Piñol and I am a research physicist in the Applied Mathematics Department of the Polytechnic University of Valencia.
Hi, I'm Francisco Escolano from the University of Alicante. I'm professor in artificial intelligence and expert in information theory for computer vision and pattern recognition.
Hi, I'm Cristina Polowskaya and I'm student researcher in the University Institute of Research Center for Operational Research of Miguel Hernández University of Elche.
Hi, I'm Manuel Portoles, a computer scientist from Universitat Politécnica de Valencia, and I'm helping Valencia IA4COVID with the web development and video production.
Hi, I'm Miguel Rebollo from Technical University of Valencia and I'm expert on multi-agent systems.
My name is Miguel Ángel Lozano and I'm lecturer in the Computer Science and Artificial Intelligence Department of the University of Alicante.
Hi, my name is Miguel Ángel García Marc. I am distinguished researcher at the Pure and Applied Mathematics Institute of the Polytechnic University of Valencia.
Hi, I'm Oscar Garibu, a contract researcher at Universitat Politécnica de Valencia. I work in applying artificial intelligence to fields like fraud, and anomaly detection and anomalous diffusion.
Hi, my name is Victor de Lena. I'm a social media manager in Valencia IA4COVID team. I'm postgraduate in transmedia communication, and please follow us in Twitter and LinkedIn.
After having been during 1 year making predictions of the evolution of the pandemics for the Valencia regional government, they are expecting more of us. They want to know what will be the different scenarios that we will have when taking different types of decisions. And when we found the pandemic response challenge, we found it perfect for stimulate our work working in two lines. On the one hand, to improve the predictive models about the evolution of the pandemics, and on the other hand, for trying to provide a catalog of prescriptions for our government in order that they can decide what is the optimal decisions to be taken.
In fundamental ways, thanks to the development of data-driven machine learning models that enable us first to accelerate the discovery of effective treatments on vaccines, also to support clinical decision-making via algorithms that automatically diagnose the disease in X-ray imagery or predict the probability of need intensive care based on symptoms, medical history and demographic factors. And finally, to support public policy making via evidence-driven models. We are confident that the work carried out by our team and also by other teams in this challenge will contribute to advancing towards more evidence-driven approaches to public policy making.
We are special because both in our predictor and in our prescriptor we rely on a mixture of models, because we firmly believe in the power of using complementary approaches to build more robust systems. Our predictor, for instance, is a bank of recurrent neural network-based models. This enables us to be more flexible to cluster pandemic regimes of different regions of the world. Our prescriptor, on the other hand, combines two different models in order to identify the Pareto optimal set of solutions. First, a neural-evolved model. Second, a model based on the RNN synchronization principle that we discovered during the challenge. This principle states basically that if you freeze the vector of NPIs for a given country in 60-90 days, it will converge to the same value, all the countries will converge to the same value of the RNN. And this value allows us to build the third element of our approach, which is a feature importance based greedy method. We are also different from other teams in that our models are being used by the Office of the President of the Valencian Government in Spain since the start of the pandemic. And this is really very exciting. This is the truly experience that made us come in age as a group in conjunction with the XPRIZE challenge.
For the prediction task, we built a bank of models. First, we perform a non-supervised clustering based on the number of cases per 100,000 inhabitants for each country and region. Then, we selected 8 clusters which we used to train 8 models which cover 103 countries and let the rest of them being evaluated by a general model trained with the 20 most affected countries by the pandemic. We implemented an architecture with 2 LSTM-based branches, one for context, where we analyze the time series of the reproduction number, and the other for the action, where we analyze the non-pharmaceutical intervention time series. In the context branch, we have 2 different architectures, one for the reference model and the other for the 8 clusters models, and depending on the country and region that we evaluate, we choose a model. The reference one has a convolution layer followed by a bidirectional LSTM and finally a dense layer. On the other hand, the clusters models have 2 convolutional layers and 2 bidirectional LSTMs, and as before, a final dense layer. In the action branch, which is the same for all the models, we use a similar architecture, but without convolutional layers, and using 2 dense layers to smooth the output. The 2 branches use the data from the last 21 days to make predictions that are combined into a final dense layer to get the reproductive number prediction for tomorrow.
To build our prescriptor, in first place we performed an analysis of the problem space. We found that a given NPI vector led to the same convergence RN in all cases. Thanks to this finding, we could obtain the Pareto optimal front of intervention policies from the mapping between NPIs and RNs. Unfortunately, there are more than 7 million combinations of NPIs, so that we opted for computing a sample of this mapping. We carried out a feature importance analysis and discovered which the interventions are the most important, and we added to our sample all the combinations with these interventions. As a result, we obtained a mapping between more than 54,000 NPI combinations. At runtime, given an input cost vector, we compute the stringency of each row in this matrix and identify the NPI combinations that are in the Pareto front. We select the 10 best NPIs that satisfy that they are not dominated by any other NPI and contribute to cover the full range of possible stringency values. Finally, with these NPIs, we compute all possible combinations of subsequently applying the selected NPIs in chunks of minimum 14 days, and we identify the Pareto front of these combinations, from which we obtain 10 prescriptions.
I would say that we found it very interesting to evolve the architecture and parameters of a neural network to try to build a robust approach to provide Pareto optimal prescriptions under any cost policy. We learned a lot about neuroevolution and experimented with different key modeling parameters such as niching, number of hidden layers on the connectivity, and the fitness function. We keep experimenting and evaluating neuroevolve solutions, as we would like to have an approach as robust as possible.
This challenge has enabled us to push the state of the art on using machine learning-based methods to support public policy making during the pandemic. We believe that this challenge will give visibility to the immense opportunity that we have when we bring together machine learning experts, data scientists with domain experts and policymakers to support more evidence-driven policymaking. We believe in the power of using data and science for social good. This is actually the main motivation for our work.
We have been working together as a virtual team since March 2020. We heavily rely on technology to enable us to communicate, coordinate, brainstorm, and feel that we are a team, even if we haven't physically met. We have a Slack channel that we constantly use. Also, we organize daily sync-up virtual meetings via Zoom or Google Meet. We use cloud infrastructure for document sharing. And finally, we have a GitHub repository for our code. Without technology, we will not have been able to efficiently collaborate. We have learned a lot during these 11 months of intensely working together, on weekends, holidays, and so on. However, we also look forward to being able to physically meet.
My family back in Russia is very proud of me for having been part of this challenge. We are living a historic moment. I feel lucky to have the opportunity to work on solving a global problem. The fact that I have contributed to building a solution to tackle today's pandemic using my expertise in AI seems amazing to them. They could not be prouder of me.
Feels so bittersweet knowing I can leave. And it tastes like candy.